Lesson 5.8, simplifying square roots. So if you thought we were over with square roots, golly, we're just getting a good start here. Page 423. Couple properties there that are good to recognize and at least understand how they work would be in green, bottom half of 423. First one says if we have two numbers, and let's call those numbers A and B, and we're multiplying them inside the square root, that means that's the same as the square root of A times the square root of B. Remember in the last lesson we had an addition sign there, and that is not true. If this was plus and this was plus, that would not be a true statement. Well, let's plug some numbers in here. We're going to say that the square root of 4 times the square, oops, I don't want to put a square root sign in a square root sign, at least at this point in your math career, maybe later on. Okay, square root of 4 times 9, that I'm saying that equals the square root of 4 times the square root of 9. Alright, let's look at this. 4 times 9 is 36, so the square root of 36 is 6. Does that equal the square root of 4 times the square root of 9? Yes, it does. So that is a true statement there. And if you look at the next little green box they give you there, we've got the square root of A times A. So we've got the square root of A times A equals A. What that means is the square root of 3 times 3 equals 3, because 3 times 3 is 9. And the square root of 9, what number times itself gives me 9? 3. So that, again, is a true statement. And the reason they give these properties is because in order to solve some of the stuff in this lesson, you're going to need to know the truth of that. Alright, so what we're going to do is we're going to simplify square roots. We're going to reduce them. Up until this point, if you multiplied or got an answer of a square root of, let's say, 50, you'd plug it into your calculator and get a decimal. Well, that decimal is just an estimate of what a square root of 50 is. If we want the exact square root of 50, actually we can't find that in a number form, but what we can do is we can simplify this. It's kind of like taking, again, a fraction and reducing it. We're taking the square root of 50 and I guess you could say reduce it, but actually we're simplifying it. We're putting it in a simpler way. Although what it looks like won't appear to be simpler, it actually is. So what we do as far as simplifying a radical is we do our factor tree. We find out that what all of the, oh, that wasn't a very good one, putting 3 there, putting its factors down in our factor tree, and just keep going here. So my prime factors of 50 are 2, 5, and 5. Alright, so when I teach this to high school, or what I normally do is I tell them, I said, pretend that this is a house. Alright, and there's all these numbers inside this house, and right now these are the factors. So if I put the factors in here, this equals 50. 5 times 5 is 25, times 2 is 50. So by breaking it down to the prime factors and taking the prime factors and putting it in the house, this is going to be equal to that. And what I tell them is once you've got this, you've got this couple that want to go out for the evening and they're going to leave the house. Okay, but they are one couple. There's two people, but there's one couple. So you're going to take that one couple, move them outside the house, and anybody that's not in a couple, which obviously would be just a one number by itself, would be left in the house alone. So 5 square root of 2. 5 times the square root of 2 is the simplification of the square root of 50. Alright, so let's try a couple of those. Let's do one like the square root of 45. Let's go ahead and write it as it's the prime factors. 3 times 3 times 5. 3 times 3 is 9. 9 times 5 is 45. I take my couple, move them out, and my 5 is by itself. It stays in there. This is the part people mess up. They'll put a 9 out here because 3 times 3 is 9. You're not doing that. you're taking the couple out is one couple, and you've got a 3 there. I know it's kind of silly the way I explain that, but it does really help to understand that. Alright, so let's try one like example 2 on page 424. Square root of 18x squared. Let's break this down into its prime factors, and then we've got to break the variable down into its prime factors. So this is going to be 3 times 3 times 2 times x times x. Anytime you're breaking a variable into its primes, it's just going to be x times x, because there's a 2 up there, and so we have 2. If this was a 3, there'd be 3. If this was an 8, we'd have 8. Okay? So now we circle our couples. There's a couple, and there's a couple. We're going to drag both of those out. So we're going to take our couple of 3 and our couple of x, and we're left with a 2, and that's simplified. We are done. That's all there is to that. Alright, let's try the next example here. Example 3, square root of 180. Again, we're going to do our prime factors. 2 and 90. 2, 45, 9, 5, 3, 3. That's as far as we can go. So my prime factors are these. So I make a really long radical sign. Okay, so I'm going to pull couple number 1 out of there, my 2's, grab that one, so I'm going to pull my 2 out. And I'm going to pull my 3 out, and I'm left with a 5. Notice, I pulled 2 numbers out. I've got a multiplication sign between them. All I have are multiplication signs here. So I'm going to keep my multiplication. I'm going to pull a 2, pull a 3 out, multiply them, get 6 square root of 5. Okay? And that is 180, the square root of it, simplified, and you're good if you can get that. Okay. Let's do one more, and we'll call this lesson good. It's a little bit short. Example 4, we've got 48x cubed in a radical sign. So we're going to do our prime factors here. 224, 212, 26, 23. Okay, so 48 breaks down to, let's put it up here, 2 times 2, 2 times 2 times 2 times 2 times 3, and then we've got 3 x's times x times x times x, all under our radical sign. Let's get rid of our prime factoring here. Now we're going to look at our couples, pull them out. We've got a couple here, got a couple here, got a couple here. So we're going to pull this 2 out, pull this 2 out, pull that x out, and we're left with a 3 and an x. So we're going to have 2 times 2 is 4, times x is x, 4x, 3x. Alright, so we couldn't pull this x out because there was only 1 left here, because we pulled 2 of them out. And these 2 we pulled out, we left the 3 in there, and that is our simplification of the square root of 48x cubed. Alright, so that's it for lecture 5.8. Let's go ahead and do some problems.